So I'm probably best known in this context as a guy who created Jenkins, and that was part of my, well, I guess part of my thing into the developer productivity. But actually, I've been in this space for past 20 years. So and throughout that time, a lot had changed. And then, so today I wanted to kind of talk that story, and in this space, like what I saw evolved in this industry from the early days of developer productivity to where I think it is today, and a little bit about like what's coming, in my opinion. And in the process of talking to people in conferences like this, what I often find is that I guess the vendors or what the media is talking about the state of the art today is often not what people are doing in day to day. And there's always these people feeling like, oh, like we must be so far behind. Well, I'm hoping that this journey, this history of 20 years kind of give you this mental picture of where you might be on that journey. And there's some, and then kind of helps you where you could be next as opposed to where you're supposed to be. So this story starts from 2000. I was a lot younger, obviously. I was actually like right after the college. So I had my own little company with my friends in Tokyo. Selling computer software, it's very easy, right? You just need a computer. So even a college kid could do it. So we rented this apartment next to our campus, and we lived there. And that was office / our home. So during the day we go to the college, come back and do some work, and then we amassed this like a huge video game collections, and we played those over the weekend. It was quite fun time, and I kept doing that after a few years, like in graduating from the college. So it is cool. I felt it was cool to run a company, but I started to feel like, okay, this is actually, what I was actually doing is, I guess the work for hire. So like some people who needed software written contact us and get the software written. So at some point it started feeling like, okay, this is something I could do anytime. And that was when like one random email arrived in my inbox, and that was from Sun Microsystems. For whatever reason, like they found out about what I was doing, and they had this job offer, and that was a job offer that was hard to refuse, right? So and then I was young, so this idea of coming over to the U.S. and like rebuilding my life from scratch felt like sure, why not? So I moved to the U.S. and of course I have to decide if I'm gonna part my way with my girlfriend. I'm gonna marry her. So I proposed and like she accepted. So like I got new job, a new place to live, a new wife all at the same time. So it's quite a time. But I actually don't know where I'm going to stay. Like, and this was early days, so there was not a lot of real internet. So when I landed to San Francisco airport, I didn't know where I'm going to be staying at that night. So I'm really grateful my wife to like follow with me. This is quite unplanned in terms of like what I wanted to do. But anyway, Sun Microsystems was actually a great place to work. Now, I'm sad to say probably many of you don't even know that this company, like nowadays, right? It's gone for like a good 10 decades. But back then, this used to be like a tip of it's the best of the breed of the tech companies. What they were doing is like essentially selling a tool, well, let's see, selling servers for .com companies. So the .com companies themselves like went bust left and right, but we are like arms dealers selling to wars. So like that was a guaranteed position, like a good place to be. Now, but .com bubble has busted, and by the time I arrived, it's already like that day was behind, not in front. So I kept hearing from my colleagues that back then they are like company retreat was to put everybody into the airplane and send them off to Las Vegas, and then 2 days later they come back with like a groggy eyes. I missed all of those. For me, the company outing is a picnic in the park nearby. So that's how like the sun came down that quickly. But I was working on the Java platform, Java Enterprise Edition more specifically, and then so we are building a platform. Now, in this company, like I could already see in retrospect the beginning of the like a developer productivity. So more specifically, it was actually back then called the release engineering, and that was somebody's job title, a role. In fact, there's a whole team of release engineers. And then so what they did was every release engineer is assigned to 4 or 5 different software projects, and then helping them sort of run the build and run the releases. They must have felt, these people aren't, I'm not sure what's a correct way to say it, but they've seen as sort of a second-class citizen, right, from the people writing production software, rightly or wrongly. Right? They felt like it's a support staff. So it was, but with that said, I think the importance of what they bring to the table was pretty clear. So, for example, one of the key jobs for them was to, assign the numbers to every build that comes out every night. That's called official build, and then those are the builds that then get consumed by the other teams, like a testing team. So if you run Java, I think they are probably still doing it. You might see a version number followed by B that stands for build, 157. What that means is that this is 157th official build that came from the team, and only the release engineer was able to create this build. And then so that has this effect of clarifying exactly what set of the source code became a binary. So later when it gets tested and they find a problem, engineers know exactly where it came from. So in the larger software, those things are crucial. So the one of the key motivation for having this official build is that the QA team was running the tests nightly, and then they have automated this, and then every morning we show up to work to see the results of the last night test result. What a depressing way to start the day, right? You see all the regressions that it caused yesterday, the first thing in the morning. But that was kind of how it was. Now, the effect of having this email arriving in your inbox in the morning was everybody in the team knew what the state of your software was. So it's sort of have this effect of bringing people on the same page. And then that was actually pretty important because back then I remember making phone calls with my colleagues, okay, that this software doesn't build, or these tests are failing, and I don't think I'm responsible for this. Did you touch that file? And he's like, no, it's working fine for me, So that was. Yeah, exactly. So, sometimes, nowadays maybe we feel that for granted, but I think this is still to some extent true. People in the team are not exactly on the same page about what's working, what's breaking, and then so on and so forth. So the other responsibility of release engineering involved managing the release lab. So they literally had this room with this huge air conditioners, full of computers racked up, and then those are used for building and testing. Now Sun, we are shipping the software that runs on people's computers, so we had to test our stuff on Windows and Linux and Solaris. Remember that these things existed back then. So there's all sorts of different versions in different hardware. And so it was just their job to keep them maintained and up to date, and make sure that the disk space is available and the network is connected and nothing is finicky. So that was how Sun operated around 2005. Another thing I think that was noticeable back then is the engineering and QA were in the different organizations. And then I suppose in retrospect, it made a lot of sense for them because they are originally a hardware company, right? So the engineers were creating this a crazy hardware, and their job was to ship something, however crappy they are. So the QA organization needs to kind of work as a reality check, a gate. It's almost like a mother trying to make sure that the kids don't mess around the house too much. So naturally, they had to be, there's a little bit of tension between those orgs, almost designed as a structure. And nowadays, we kind of talk about this as if that's a bad thing. But there's actually, I feel like there's some positive aspect to this. One, these QA organizations, they were really good at breaking things. Right, so they know okay, so the moment they find, let's say, something repeatable that you can input to the program, so they instinctively just 100x the input and to make sure the software could behave. So that's one of the very common patterns where the QA engineers know how to stretch the system. Now, when you leave the developers to write tests, they tend to focus on getting the right things correctly. They don't. It's difficult for them to really like bring their mind into the side who is actively trying to break things. So that was good. The other thing is the boundary checks, or that the make sure that the spec and the implementation are aligned together. Now, sometimes this different perspective is helpful. Obviously, like there's a bad side to engineering and QA in a separate org. That the QA people can often just test from exterior, like they can't really get into the system itself. So that often put them into this disadvantageous position about what can be tested. And then so, this was actually around the time the idea of the unit test, which nowadays we take for granted, but back then that was actually a new thing, became real. So engineering started to write more of the testing and so on. So in some sense, it's actually quite complementary, and in that respect, there's a lot of logic to that. That made a lot of sense. But then, they nightly just started becoming not enough. Like it's just doing the test and doing the official build and doing the official test. That's a wonderful concept, but having that just once a day was just not fast enough. So we started like that pain started feeling, and I also was a guy who is known to break builds. So like I often fail to commit. Like I'm working on this change, I only commit this part and forget to do that part and stuff like that. And so I get the phone call from my colleagues like, okay, I updated my workspace and it doesn't compile. And did you, any chance you know what it is? And then like, sure enough, I have stuff lying around. And I also remember like making a phone call into release engineer, like we need a new official build because this other team who depends on the stuff needs a fix now. So at some point I started feeling, okay, this doesn't, it doesn't really feel like a human's job. We should be able to like use the software to kind of run these things. And that became Jenkins. And originally, this thing, yes, well, even before that, this software was named after my own release engineer. And I felt, okay, this is probably not a good idea. Like I'm actively trying to replace her with a computer. So I was smart enough to rename that into something else that eventually became Jenkins. So that was actually, like initially it was my side project and fun, but once that I have this platform available, people started putting all sorts of workload on it. So it kind of happens all the time, right? If you make something easier, then more people use it more actively, and then that sort of like pushes the boundary a little. So official build came on to this like a nightly test, like integrations, the static code analysis, the code coverage, and all sorts of random crap started piling up on top of it. And it was fascinating and they scared because this was my weekend hobby projects, and now people in my day job was seriously depending on it so much so that if this thing goes down, then the official build from this team doesn't go out. But anyway, so that enabled me to, so I started blending the boundary between my work and my hobby, and my boss often tells me okay, we need this bug fixed now, so you can fix that. A bug in Jenkins fixed now because, otherwise build it, tested stop. And then so it started becoming my day job. And then so that was the fun time that I had. Now, while I was having that fun at Sun Microsystems, the rest of the world actually have been changing quite a bit rapidly, and then that eventually led to Sun's demise. But anyway, so what was going on was this, the cloud started becoming a thing, a real thing. And then what that meant was that there's a lot more computers are now available at quite a cheaper price. But humans are not getting cheaper. Engineers are actually getting more expensive. So what that meant was, economically speaking, it made more sense to harness more computers for every engineer. That became more effective mix of capital. Right? So that means, okay, so what that means on the front line is that every developer needs to kind of find a way, every organization needs to find a way to use more computers to make every one of us more productive. And that had to be invented. And then that's that was what's happening in one key part of space. Now, I have to say, this is obviously a cloud is the main thing. That's so obvious in 2023. But there's actually a sizable part of our industry where this is still not the case. If you're developing embedded devices, medical devices, stuff like that, where your software needs to run on the actual physical thing, and then testing requires this huge equipment, then you're not really at the place where the computers are abundant, right? So sometimes these people almost feel defensive and apologetic that, oh, our testing methodology is so prehistoric. It's actually not. For their economic context, that is just not the reality. And engineering is always about finding the right solutions in the right it's the given context, right? So sometimes I see a lot of people struggle unnecessarily because they're trying to apply the solution that's designed for the other kind of context and just blindingly trying to bring it to their own world. But anyway, so Sun was not a cloud company. It was the opposite. But I felt, this question of how do you harness every developer with more computers was very much real. So I started collecting computers at my work. And this was around the time at Sun Microsystems where things are going down the tube. So layoff after a layoff after a layoff. And every time a layoff is announced, and then we get the company email, right? So, and then I find that who gets sacked, and then I go to their offices to steal their computers because they leave the desktop computer behind. And I collect them under the printer room, so that I hijack the printer room into my own handmade lab, and then that became the Jenkins cluster. It was a very insensitive. Well, I didn't see them because they're already gone, but that was an interesting time. And then, Sun was also selling this virtualization solution. That was the thing back then. So one huge computer sliced up into different ways. So the corporate IT was running this program in which we can trade in the physical computer, and they give us a slice of the virtual computer, except they actually didn't verify that they're receiving the computer. So I traded in my hardware, I kept the hardware, and I got this virtual machine, so it suddenly doubled my computers and loved it. Or sometimes this a computer labs, they have all this random testing software, testing hardware, but when the team, a reorg happens, these things get orphaned. And so I occasionally go into the lab and just randomly power off the computer and then come out. And 3 days later, I go back in. If the computer is used by somebody, somebody angrily stormed into the lab and bring the power back on, and I could see, oh, this is used. But if it's still powered off, that's mine to take, right? So I store computers that way, left and right. And then so Jenkins acquired this, distributed build capability, and then it got better. This was also around the time where Git became a real thing. And then one of the things Git enabled was this idea of testing before committing or testing before merging. So now we call them pre-merge. Back then, there is this so that was actually a pretty crucial, a key. It's a very innovative approach, right? So when you're testing because you are testing just your stuff, anytime anything breaks in there, you automatically know that it's your change that's to be blamed. And then before that, and I think people still do this. If everybody is change is landing into the same main branch, and then something breaks, and somebody has to go triage, or this failure that happened, who is likely to blame? And that requires human manual labor. So this was one of the ways in which we figured out how to harness the power of the more computing power into making us more productive. So back then there was some effort to try to recreate this kind of workflow on more legacy version control systems like Subversion and so on. I tried some of that in Jenkins as well, but then Git took over the world, so this became a non-issue. And then so in this way, continuous integration becomes something for individual engineers, not just for the team. And I can't stress enough how significant that was. Also, part of what enables testing is testing is actually a hard problem. One of the reasons is because interacting with software that you're testing is actually often painful. And then especially in the web app, right? So like, these web pages were meant for humans to consume. So it actually took a significant effort to come up with Selenium, which allowed the automation of the web app interactions, and then Appium, which is doing the same thing for the mobile. There's always, and then these are two major surface area where like, we have solved, if you can call it solved, because Selenium is too painful, let's face it. But yeah, this is doable. And it's also still in some other domains. Like if you're developing a video games, again, these like embedded devices, interfacing with the software or the hardware you're testing is still awfully challenging. So I think this space, this part is still an unsolved problem. But it's kind of on the back of these innovations that allows us to do more testing. So at one point I remember, because I was working in the Jenkins, and the inventor of Selenium was Jason Huggins, and he was in San Francisco. And I remember meeting him when he started Sauce Lab. It was just 3 guys. And then Sauce Lab became a major company since then. They are running a Selenium meetup, and then I had a talk over there. It was a wonderful opportunity. And the fact that he started a company, he's a technology innovator, right, was very inspiring for me. That I didn't know, like I was still working for this big company. I felt like that must have been a safe job. Well, it's kind of funny to look back and how little I knew about the job safety, because it was only a few years later that the Sun was no more. But this idea that, oh, you could actually start a company, because after all, it's like a Silicon Valley. And to see somebody up close doing that was very inspirational. Another, I think the key idea that came in around this time is this engineering in test. It's not the QA engineer, because what the unit test, as the unit test became like a day-to-day thing, the engineers started writing code with testability in mind. So this idea of this testing profession, the thing I mentioned to you, like, okay, if the machine can take anything in like repetition, then like just put hundreds of things in to see if they break. So those ideas needs to be kind of taught to engineers. So QA people got more embedded into engineering, and then sort of this paradigm shifting, like a computer program, like software writing. So it's like inversion of control, or application framework started written with testability in mind. So that was a major change. Now, so with things like that, it became less and less sensible that the QA is outside engineering with this tension. So QA got melded into the engineering, and that's the idea behind the engineering in test. So those are all, in retrospect, like a very significant change. Now, around this time, I think it was 2010, 11. So Jenkins really started like taking off. Like as I said, it was my fun hobby project, but people started using it. And when this was again around the time Sun was going down the tube, so people at Sun who got exposed to Jenkins like went to a different company, and I'd like to think they brought Jenkins with them. So because this became popular enough, I started. I was one of the founders of the startup called CloudBees, and then I thought, okay, maybe we can make like take Jenkins to like a higher level. So this was my first time jumping from one company, well, like a big company, to this startup, which I thought, I have no idea what it's gonna work, and like, what about my job security? My wife is super worried, right? As far as she's concerned, paycheck arriving every 2 weeks is a good thing. And then so I was saying to the club is, so we only have 6 people. Maybe we don't have enough money to run for a whole year. And that was not a reassuring pitch. But in retrospect, again, I feel like this stability is like a wrong way to look at it, right? Like it's trying to optimize one's life for the long time span is almost impossible. I think that the best you can hope for is like a more microscopically, like at this very moment, like are you working on something that you enjoy? And you kind of have to trust that your path will eventually get to somewhere, even though you don't know where it's going to take you. So that was like a great perspective change that the CloudBees gave me as working for the startup. The other thing I discovered quite interestingly is like I was in the Silicon Valley, but it turns out that sort of like a network of people in the large companies and network people in the startup are entirely different. So even though we are sharing the same physical space, it's almost like a two different layers exist. And I got to jump from one to the next and discover a whole different part, and that was interesting. CloudBees was also a very distributed company. People all around the world, we used to joke that our engineers hate each other because no two people live within 50 miles of each other. But so I got to travel around the world, and that was fun too. Now, when I was traveling around, because I was a creator of Jenkins, I could just go ask for people to meet me, and then I tell them, like, I've been in this city in such and such date. I love to talk to people who are developing software, and then just random people write to me and invite me to their offices and just give me earful about like what their struggle is. So that was a wonderful opportunity to kind of keep the tab on the pulse of the industry. And what I discovered is what I'm hearing in the conferences as a cutting edge practices was entirely different from people's like day-to-day challenges. And then so that was an interesting, important perspective for me to keep in mind. That the things you hear in these conferences, including mine, cannot be always trusted, right? So what was actually going on in these companies? And there's a different variety. So one of the typical patterns I see is like a medieval Europe. Well, this is probably not a medieval map, but you get the idea, like a medieval Europe style. It's in a large company, like a lots of different like silos or different like teams doing things in their own ways. Because often like they came together through acquisitions or just like regulatory reasons, like they're separated around. Pretty much all the financial sectors are like this. Like every application development team has their own kingdoms and have different customs. So that was in reality in which somebody up there says, okay, like we need to kind of like shore up the entire company, and that's when they create this team that drives the CI or CD. Or I suppose nowadays they might say DX, right? And then so what happens? Because these people, this newly created centralized center of excellence DevOps team has this major challenge. So one of the things that they typically do is to focus on what I think of as a provisioning. That is because they have so many applications, like a new one is coming up every day or every week or something like that. And then so this new team that forms needs to set up this basic ingredient of software engineering, right? Like, they need a source code repository, they need a bug tracking system, they need a CI system, they need like a wiki. So people started focusing on giving them that, like a mix of that very quickly, pre-integrated. And then the idea is like if everybody is using the same set of tools, then hopefully that will drive this like standardization almost. So I've seen a lot of companies who is trying to do that, including, and some other like system integrators often do this again for the same reasons. And then some of them get to the point where like they even generate the initial skeleton of the source code, the default CI pipeline. And this practice eventually became called the zero feature deployment, meaning, you get to this, you have this whole like kata of delivering software figured out even before you have any feature for the software itself. So that's good. Now, the next step from that for these guys is often this centralized infrastructure management. Back then, it was actually still common that every team runs their own stack. Like, there's a Jenkins guy in every team who's like run the Jenkins on their own computer. But they are also that became kind of inefficient and insecure and all sorts of bad things. So people started trying to consolidating that into the central place. Now, most of the software that I mentioned earlier on, like a repository managers and so like a bug tracking system, when you try to like concentrate a large amount of it in one place, it actually makes the life hard beyond certain scale. Up to certain scale, it's good, but beyond that, so I've seen a lot of people who struggle to babysit Jira server or Jenkins and so on. So it became kind of like an internal SaaS, is inside a corporate firewall. But anyway, so the common challenge for these guys wasn't actually that layer running the software. It turns out that the running the common piece of software like Jira and Jenkins doesn't actually drive this like common way of doing things. There was still like a feudal Europe, like the Brits will speak English and the French people speak French, and like they have a different preference to the T's or whatever. And then so that, and then without the standardization, like you can't really like drive the economy of scale. So these people really struggle to drive uniformity. And when I try to put myself into their shoes, like I just feel almost like sorry for the impossible tasks they have. Like thousands of engineers working on hundreds of different apps, all run differently. Like how can you help them all at scale, right? And it's just, and then you are like, in the meantime, while you're struggling, you're on the 5-year plan to do something, and you're left behind by the competitions. Now, another common pattern in these places is what I call the internal evangelist. So, what happens is, you are the center of excellence DevOps team, right? Your team is full of experts of DevOps, but because every village, every app is doing things differently, the way you help them is you send one of your guys as an evangelist into that village, and he's going to evangelize the team. It's a good thing to write tests. Okay, you can use this thing. Okay, here your tests are flaky. I'm going to help you reduce the flakiness. Whatever the project is, they go on and they make an impact, and they come back, and they are now on the mission to a different village. Right? And then so you convert one village at a time. Which has a benefit of, like being able to make an impact, right? One of the challenges of this centralized CI/CD system is like, it doesn't particularly fit the needs for anybody. I mean, so often they struggle to make tractions. Like in this scheme, if you're internal as monolith, you always make an impact because what you do, it's fundamentally local to the village that you're assigned to, but it doesn't scale. And then so that's kind of impossible in that regard. But in retrospect, maybe it is actually like if you're trying to unifying the culture of this like a diverse set of app development team, perhaps it's just like an impossible task anyway. So maybe it is not a surprise that there's no silver bullet. Like maybe it is the kind of thing that takes years, and perhaps like a larger companies are making enough money that they might be able to tolerate these things. So far I've been talking about this like, medieval European thing, but there are some small number of companies in which they have already like unified the whole Europe. Well, now I suppose, I don't know if it's accurate to describe America as like a unified nation. You have, different people might have different thoughts, but at least we have, like a centralized government. We are using the same unit of measurement everywhere. I can drive from San Francisco to New York, and it's kind of same deal. There are some companies like that, indeed. I don't know, like a Salesforce or Facebook or Google, where there's one way to do things, and everything else is just, well, occasionally there's like a minor peripheral thing, but stuff that matters gets done in this one way to do. And then so, by and large, these places have this huge monolith, and that's like what drives this uniformity. And from the perspective of these like guys that I was talking in the previous slide, this feels like a wonderful world because now, you change one thing in this monolith, and it suddenly benefits everybody working on that thing. So you have a high leverage to make things better. It sounded like a good thing, right? So these places often have a build guy, not just one of them. It's a whole team of build guys working on, or like a DevOps experts and building on the custom test framework, the CI process, or their own unique delivery process. And these people working on such a sophisticated, like narrow vertical program that's like inherently tied to how they do things. So in the first glance, like from afar, it sounds so cool, right? The sophistication of the problem that they're solving was amazing. Like I remember talking to one company in Israel. I went there, I met with a team who was like, there's a dozen of them. and I ask each one of them what they're working on. I remember one guy saying, like our production system gets like a billion hits per month. So we have this system where engineer can deploy a change that's in a pull request for like a 0.01% of the production traffic. And they can measure the KPI change to those to decide if it's causing a regression or not. And I was like, wow, this is so sophisticated. I've only seen so many places where this is actually done. So it's wonderful in that regard. And then, however, every team that you go built this different system that really takes advantages of the business or the software situation that they're in. So it's almost like seeing a different kind of flowers bloom. And that's a wonderful feeling. I still see that there are a number of good ideas in those places that I'd love to kind of port over to the rest of us, right? So I'm still looking forward to doing that. It's wonderful. However, the challenge of this, the flip side of this, like highly centralized monolith uniform place is that it's so easy to kind of get into their own evolutionary dead end. Because if you take this incremental step that's all sensible, like you start to diverge from where the rest of the industry is, right? Because your situation is unique, and in some sense, you're getting better by leveraging that uniqueness. So the rest of us kind of benefit from each other building these crappy things, right? But because there's so many of us, and then like building so many of things, at some point you're like, if you're going astray, then you won't be able to benefit from all that's happening in the rest of the world. And then so what that happens is like when the ice age comes, then you die where the rest of us, because we have always been miserable, we kind of keep carrying on, right? So what happens, like people in there like recognize that risk, but they don't, like incrementally they're making optimal decisions, they just can't turn around. So I've been invited as a guy who invented Jenkins into these places where they have this massive CI system built, and it's like working like a well-oiled engine. But they know that they can't be on that path. Like their job is not to create a CI system. Like their job is to serve the salespeople or a marketing effort or whatever. So they want to switch over to Jenkins or something else, but there are people who are like working on that system for like 5 years. They're feeling like they're rightly pointing out that Jenkins can't do this or can't do that and something else. So there's this massive fight going on, and I was a guy in the middle, like I get shot from all directions, and that was so things that happen. I think more and more people are recognizing like this danger of doing things on their own, but there are still places like Google where they just have this like their own way of doing things. And to their point, there are some of these like a large-scale software development problem is still not very well solved in these like commodity software, because most of us aren't working on that large-scale software. So there's some real pain in there. Now, I guess, sorry, still in Japanese. Well, I forgot to translate this one. So, and then that was another, while I was having fun doing all that, like another major thing that's happening in this world is a SaaS. Right? So back then, this was, I guess, maybe like 10 years or so, like things becoming more and more SaaS. So Selenium became a SaaS solution, right? Like a Source Lab. CI system became a SaaS, like, I saw Circle CI guys, you said, and so stuff like that. So now I feel like if you're walking around a conference like this, you might feel like everything is SaaS, but it actually, like in reality, things is still in transition. And I kept like getting bitten by that. So right now, my company is SaaS only, but what that means is like I can't really serve some significant chunk of the market because they are still on-prem. So the vendors are like really struggling to support both of those worlds, and it's not easy. Now, on the other hand, the more and more companies are building SaaS, right? Like a Salesforce, their solution is SaaS. I don't know whoever, like, well, GitLab is not, I guess, SaaS, but I'm sure you use like a lot of SaaS solutions. So people who are selling SaaS, they do not really have problem consuming SaaS. So like these guys can go to host the source code on github.com, use Circle CI, or like use a Salesforce, and like it gets lots of things. so you know, so that creates this ecosystem of SaaS, and because the newer innovations nowadays happen in SaaS, the packaged software that people run on site is sort of, you know, is behind. So when you're when you're not one of the companies who are like born in the web and then we have a DNA that can consume SaaS, you sort of started to lag behind, and that I think is creating this like a strain in the industry. So people in the web, their developer productivity approach has evolved tremendously in the past 10 years. So most of the newer things we are talking about, you know, like a microservices or service mesh or feature flag or whatever, like circuit breaker, all sorts of interesting ideas, they all came from the web service development world. But like I said, you know, the entirety of the software development ecosystem is a lot larger, right? There's this packaged software, embedded systems, game development. None of them will be moving to the, you know, none of them are web services. Yet the way they develop software is still largely the same from 10 years ago. At least I feel like. So I think there has to be some innovations. You know, these people have a higher pressure than ever to deliver software. If you talk to engineers working on cars, software engineers working on cars, they tell you that the amount of software in things in it is like a tenfold from the past few years ago. But the way so you can't keep developing the software in the same way if you have to develop 10 times more software. So they have to, something got to give. So I think this space is going to be interesting. I don't know exactly where things would break and how they evolve, but I feel like that's still not quite happening. But you know, like, so, and another thing I noticed that what prevents these innovations in these places, like people are not moving around. You know, when the Sun went bust, people moved over to different companies. I feel like the web services side of the house, engineers are moving from one company to the next, like carrying forward the idea or the practices. And then, but if the people are not moving around, if they're not really eager to talk to each other, like car companies, then that is, you know, that I think tend to create the stagnating ecosystems. I also started lately noticing that some companies are investing in developer productivity because they need to retain engineers, and that's like for me a new notion. Their engineers are getting poached to the likes of the Google and Facebook and whatnot, not only for high salary, but because the development environment in those companies make people so much more productive. And then so they are forced to. I met one VP of engineering where their main business objective is they have this like annual developer survey of the engineers in the team, and their score is like directly responsible for the bonus payouts of this VP of engineering. And I thought, wow, that's cool. Oh, that's a super cool idea. If I ever get to hire my own VP of engineering, I'm going to do that. So the people like that exist. So, okay, so far that's like, you know, what was happening. Now, where this is going, it's always a fool's errand to try to predict the future. But I feel there's a few things that I'm noting with excitement. One is like where this idea of provisioning is going next. Like I talked to you about the provisioning of the team level infrastructure, but clearly like a set of people working on making the developer environment provisioned on the web. Now, most of us, like who work on the code day in, day out, this happens only once, like to set up your own laptop for all the right tools and so on. So you might not recognize this as a pain. But as I moved over to the other, like I'm no longer like an engineer. My job title is no longer engineer, so I only occasionally help them. And then when I need to come back into the software engineering, like I realize just how painful it is to set up that environment. Like it almost takes like 2 or 3 hours just to get the environment done, only to make like a 15 minutes fix. So people are trying to move this over to the cloud, as you probably know. Like stuff that used to happen in a laptop is now more and more moving to the cloud. Now, what that enables, among other things, is that now you can harness a lot more computer. Because a laptop, you can only put so much computing power on it, but on the cloud side, well, it's not so much. I mean, that is no longer a constraint. So you can also, that's a lot more secure InfoSec-wise. Your laptop, even if it gets stolen, your source code is not in there. So I think this is clearly a thing. I used to laugh at the idea of the IDE in the browser, but I think nowadays, like, I feel like a minority in thinking that. So clearly, a lot is shifting. I think the another thing that's going on is the more intelligence in testing. So I talked about well, the software getting a lot larger, right? Like a 10x in cars. Now, when the software gets large, the first place that breaks down is building and testing. It just keeps getting longer and longer and longer until it starts becoming productive. And it's almost like the frog getting boiled in water feel to it, because it doesn't happen one day. Like, I'm sure you've seen the flaky test problem, right? Like, when the tests start to amass, like, there's all sorts of problems like that happens. And then the CI systems start to create more noise, and then testing is a kind of key, a cornerstone for higher level automations, like automatic merge, integration, and so on. So there's like a stuff that needs to be done at that layer to make things more productive. So so that's like, that particular thing is my focus at Launchable, what I do now. But yeah, so I see some more sophisticated practices emerging in this space in some of the more sophisticated companies. Now, another thing that I think is more and more thing is build. The testing needs to become intelligent. The build needs to be a lot more parallel and distributed. So I feel like most of us are still working in this environment where build is like like a local computer thing, right? Like, you can always build your software locally. So it's like a very serial process, but which, it's inherently limiting because the serial process can only use one computer. I feel like more and more people are moving to more massively distributed build, which also requires things to be incremental, so stuff like Basel. But it's such a fundamental shift, and changing build system is so painful. So I think this progression is still happening slowly. But I think pretty soon, well, at least for the significant chunk of the software industry, I bet that the build becomes something you can no longer run locally. Just like running email server locally is just not a thing. Right? So when that happens, again, we'll be able to harness a lot more computer to run in the build and test. And I think the whole paradigm, what we picture today as build and test, is going to really change. So all of that is to say, I think the more computing is getting more and cheaper, people are getting more and more expensive. So we continue to need to find ways to use more computers to make ourselves productive. So in other words, like a more cloud, really. So I started feeling, okay, the developer productivity work, sort of like a change, left the CI. Well, CI is still a thing, but it's kind of like a table stake. And then also felt like a CloudBees, which I worked as a CTO for the longest time. It was a wonderful organization, but it kind of got too successful and too big. And I kind of liked a smaller company and smaller team. And then so, I started feeling, okay, I learned a lot in CloudBees. I wanted to do my own thing. So I left that company, and then I started a new company called Launchable. That was 3 years ago. And then that's kind of what I'm doing at the moment. So, I kind of went over my 20 years in my life in 40 minutes or 50 minutes so far. Like, if you think about, like, I feel like, oh, life is so short, I only got another, I don't know, like a 20, 30 years of the life to do something. So I do have, from time to time I think about, well, there are lots of things I want to do. But given the fact, looking back, clearly, like, this developer productivity space is something I care about, or else I wouldn't be in here for 20 decades. So I feel like, I suspect that in 10 years from now, I'm still probably doing some developer productivity thing. Yeah, so I guess that's my calling. And I'm sure you have your own calling and in your day job, and you play an important role in there. So whatever you do there, well, thanks for doing that. I think we all kind of help the world go around in our own ways and make it a little better place. So thanks for you doing that. And then this is the place in which I'm doing it. So on that note, thank you very much. And if you have any questions or comments, happy to hear. Thank you. Right. So I think the question, yeah. So I think the question is, if you're in the space like embedded or like edge computing, in spaces in which this innovation of the software development is not happening, what can they do? Yeah, I don't know. So, well, I think the automation in those spaces, I think when I think about it, I think the level of automation they achieved in those spaces, I think make a lot of difference in how sophisticated you can go. So I went to this like a car company in which they have this. So they have this physical lab in which the microcomputers are connected to this centralized like node, and people can submit the workload into that like controlling software to flash the device with the software, run the test, and collect the results. And that is a better automation than I've seen in some other car companies. And that in turn allowed them to use that for any number of things, like developer running their own software under test or pre-merge testing on these places. So I feel like if you can really use these like cutting edge practices, I think the investing in automations is worthwhile, maybe. Yeah. I don't know.
Yeah, we got one over here. Just one second. Let me bring the mic so that way he doesn't have to repeat your question.
Pretty hungover. I apologize in advance.
That's a good problem to have.
I just had a random Jenkins question. Who originally came up with the workflow CPS craziness idea in Groovy? Was that you?
Yeah, yes. I think I take the credit and the responsibility, both of that. So it was, I remember that week actually pretty well. So there was this another super smart guy called Jesse Glick, and he used to work for Sun. He was actually the contributor I think the second guy to show up as a contributor to the Jenkins project. And he and I was working with CloudBees back then. So I brought him over from Boston where he used to live. Like, arrested him into this conference room for a whole week. And we together hacked this, what eventually became the foundation of the workflow, CPS. And it was quite fun. It's got, it created, well, I think every software has like the upside and downside. So I'm sure there's some problem in it as well. But I still remember that week quite fondly. Yeah.
All right. I think with that we're done. Oh, we got more? No. With that we're done, and I encourage everyone to go to the keynote. You won't want to miss it. Thank you very much.
Thank you. All right. Thanks. Enjoy the rest of Scale.